Hello and welcome to episode 3 of the EdTech Spot STEM in Education series. My name is Jonathan Richards and I am an ICT professional and freelance school educator. But today I'll be your host and co-presenter. Now our focus in this episode will be on the use of 3D design and printing in core and non-core STEM subjects. Joining us on this mission once again is Mr. Delano Payne.
Hi, everybody. How are you, Jonathan?
I'm great, man. I'm great. For those who don't know, Jelani is a STEM educator and advocate and a multidisciplinary engineer who has worked with many schools and institutions like the St. Michael Secondary School and the Caribbean Science Foundation. He's also the head coach of Robotic Adventures, which is an online digital STEM robotics program, and the author of the book Survive, Thrive, and Stay Alive in College, A Matter of Perspective, which you can catch on Amazon, and a link will be placed in the chat section of this stream. He is well qualified and from our numerous conversations, very passionate on the topic of STEM in education. So welcome back, brother. Welcome back, Jelani.
Hi, thank you. How are you?
All right. Things are great. Things are great and breezy up here. Great. So
Lucky you.
Yeah. So for those who are now hopping onto this stream, I just want to welcome you once again and to let you know we want to hear from you. So feel free to state your country, profession, and social media handle within the chat. There will be an opportunity to provide feedback on this and previous episodes. So that also will be posted within the chats. The link for that will be posted in the chats. And if you're interested in being a part of our experience, let us know in the same feedback form, and we'll be happy to discuss this further with you. So let's dive right into this topic, which is 3D design and printing. And we're going to begin with what is 3D design and printing? All right. So 3D design is a form of additive manufacturing. And there are many categories of 3D printing is a form of additive manufacturing, and there are many categories of additive manufacturing, but the one to which 3D printing falls under is the FDM model, which stands for Fuse Deposition Model. This means that the printer adds materials layer by layer. It also uses a spool of non-toxic biodegradable PLA filament, and PLA stands for polylactic acid or polylactide. So this is a thermoplastic made from renewable resources such as corn starch or even sugarcane. And unlike other industrial materials, which are primarily made from petroleum. So another way of thinking about this is thinking of your inkjet printer at home. Your inkjet printer has a print head and it releases droplets of ink on the paper, but only one layer, that is. Now, if you have a glue gun, you could imagine your inkjet printer as the glue gun instead. And with this glue gun, it heats the glue stick at the right temperature so that the glue can drop on the piece of surface or canvas. So imagine the 3D printer doing the same, heating the filament at the accurate temperature to release droplets of this filament on the plate layer by layer until it actually complete the model that it wants to. So there are various uses of 3D printing. Personal use within your homes. Let's say, for instance, that you wanted to replace or repair equipment within your home that otherwise would have been difficult to source or maybe expensive. You can actually create the design, let's say, for instance, for a kitchen knob. And based on the specifications of the stove that you purchased, that is. So here is our demonstration of the kitchen knob, a 3D design made on Tinkercad platform. And these specifications usually are online. So if you know the brand of your stove, just go online. You're able to find the specifications for your stove, maybe for each knob, and then you could design a knob based on that. If you don't know how to get that, that's okay. There's someone here at the end of the show who will or be able to help you with any 3D designs that you need. You can also contact him. The next method or example here is commercial use. And this is used with manufacturing or even prototyping. So let's imagine that you have a product you want to design, and instead of designing multiple products by hand or using the subtractive method, you can just 3D design and print those products and present those until you reach that final product. It is much cheaper that way, and it actually is time saving. And you can make edits to that design online, with a click. Even in manufacturing, we've seen even in China where some houses are actually 3D printed in 1 hour, and they're sold on the market. You can manufacture car parts, or you can even manufacture even other machine parts. Another use is in education, and this is used to create manipulatives for teaching, which we will explore in our sample project section. And finally, here for this example is use in medicine. And this is really explosive for me because we found out that scientists are using 3D printing to make prosthetic limbs, ears from cartilage, and even other organs from using human cells or organ cells. So imagine that how far 3D printing can go. We can even use it in medicine. So now that you have an understanding of what is 3D printing, I want to us to break down what is the design process in order to get the 3D printer. So Jelani, explain that for us. What is the design process here?
Okay, so thanks, Jonathan. So the point at which we start is we start with a 3D model. And that model typically comes from 3D design, or 3D drawing. So what we're talking about when we say 3D, we mean three-dimensional or three dimensions. So what we're talking about here is an object in which you're going to be able to discern or recognize height, okay, how tall something is, how wide something is, or how deep something is, okay? Um, and of course, I showed a little drawing here of an object where you can see all the sides and the surfaces and the edges, all right? And we have some examples of this. Some really nice examples, for example, uh, would include 3D drawing. So I'm going to show you something here. And, this is something that many of us have done over the years, okay? I think at some point or the other, everyone has done a visual arts class. And typically what you see is someone, just draws their hand. Now, if you look at this drawing, this is a three-dimensional drawing. Why? Because even though it's on surface, it actually displays height, it displays the depth of the object, okay, or the thickness, and then also the width, right? Now, sorry about that. Moving on to the wrong picture there. But moving on to the next example, we have a commercial example. And to give a commercial example of how you can draw in 3D, here you have a floor plan. And again, it's on a 2D surface. You're only seeing length and width on this surface. But yet, you're still able to determine from this drawing the elevation of this particular plan or of this particular area, this particular room or rooms. You're still able to discern the length, the width, where objects are positioned in place. So there's still a height, a width, and a depth. Okay? And to give you an education example, this is something that I did with my students in 2019. We actually received two robotic arms to assemble and create, right, develop. And, the parts were metal, right, aluminum. And what we realized is, okay, the metal is kind of heavy for the servo motors to lift. So could we 3D print these parts? So then that way it's easier for the motors to lift these parts. It's a lot less weight, okay? And so it has a lot more mobility. And we recognized that we had to kind of switch how we drew the parts in terms of we had to make them a little thicker, we had to change them up. But bottom line, here we have a 3D design in an educational example using technical drawing. And this is actually using Tinkercad. It's quite cool, but we'll get into that a little later. So here what we're going to do now is we're going to move on to how do we actually create these 3D drawings. All right. So in order to create these 3D drawings, we can actually do it either manually or digitally. Now, when we say manually, we're talking about freehand sketches and drawing. I am not the best at that, which is why I'm in engineering, because now I can use the CAD tools like Tinkercad and so on to do that, right? And I showed you an example of the personal example with the freehand sketch, right? And then also you have the manual tools. I showed you a little bit of an example of that with the floor plan. Before, that's how floor plans were done. Not so much these days. You have access to lots of different CAD tools and CAD hardware. CAD meaning computer-aided design or computer-aided drawing, okay? Now, so digitally, we're also still digitally using, we're doing manual drawing. So for example, you can have a tablet, okay, and you can use a stylus, somewhat like a pen, and you can actually draw on it, okay? Animators use that. Lots of different persons still use that and do freehand edits. There's actually a little bit of that. For example, I think Jonathan in the same Google suite of software, to put a plug here, right, is actually quite useful for teachers when they're showing something on screen, and they want to make a few annotations and notes, draw an arrow here and there. And then you have computer-aided drawing. One of my many skills, something that I love and I'm interested in. And by the way, students get really interested in CAD when you have a 3D printer. Watch how that works. Because you have now introduced this modality where they can physically touch for those kinesthetic learners, and there is a stronger visual aspect or connection between the visual and the ability to touch, yeah, rather than just hearing or reading about something, they get very interested. So here you have AutoCAD and SolidWorks. And AutoCAD and SolidWorks are two computer-aided drawing tools, and we'll go into these a bit more later. To give you a brief idea of SolidWorks, well, here's what that kind of looks like. Shows you what you're able to really create. And SolidWorks is more than just a CAD tool. You're able to do lots of testing with it, testing the stress, the strains, and so on, the weak spots and so on an object based on its shape, etc. Yeah, it's really, really quite intriguing. How does 3D printing actually work? Well, for the particular process that Jonathan was talking about, when we're talking about additive processes here, and when we're talking about 3D printing right now, we're really talking about starting with that 3D CAD model, that three-dimensional model that we just spoke about, and do it. We move on to conversion of that model into the type of file that the printer can recognize and understand. So we start with a .stl or .obj file, and then that file is sliced, okay? What do I mean when I say slice? Just like a loaf of bread, okay? When you make a sandwich, you make it in layers, top, bottom, and everything in between. Same thing here. Your 3D print model, when it is physically printed, it starts from nothing. You start with one layer, and then another, and then another. You lift up a little bit, and another, and it keeps going on like that. Now, when we slice something, it is converted into G code, which is part 5 here. And what that really means is it tells the printer where to go, all right? But we're not finished, because in slicing, we're also organizing the print settings. The print settings speak to the temperature of the filament that we're using, and different types of filament have different temperatures, okay? And different printers, 3D printers, have different temperatures. Also, different speeds. You wouldn't print PLA the same speed as you might PETG or carbon fiber. You might want to print it a little slower, a little faster, depending on the type of material, okay? And all of these things affect how your print comes out. Print it too fast, and the layers do not adhere enough, and then you have a problem. It might crack, or it might just not come out at all, right? You might have damage to it. So you have your G code. Your G code are like coordinates for your 3D printer. It tells the printer exactly where to go, where and when, which layer are we building now, how to build that layer. And then you have your 3D printer. It does the job. It basically carries out the G code. And the G code, by the way, you can actually read that. It is like reading a program. You can see where your printer needs to go. That's why people can make their own printers, for example. And then you have your 3D object. Ta-da, you're done. Just those 7 steps, right? Now, I mentioned materials briefly. So you have plastics, wood fibers. It actually smells like real wood when it's cut, or rather, I should say, when it is layered. Carbon fiber, metal, rock, sand, glass, and human cells, or otherwise known as organic material. The carbon fiber is interesting, for example, because carbon fiber is extremely dense, but at the same time very light. So it's very strong, but while still being very light, used in the automobile industry, for example, and even in the printing of lots of different things which need that component of light, but still have a great strength. Now, no STEM in Education series would be complete without talking about some careers. So let's talk about a few. Architect. This person builds buildings. No longer needs to use that pen and pencil and so on, except unless there's an error in the print, right? And that's the 2D print I'm talking about. And then that can be transferred to a 3D print. In fact, there are companies out there on one of my favorite shows, for example, $1 Million Listing. Love to watch that show. And what's interesting is how much people pay for scale models of, let's say, a construction project or development that they're working on. They pay lots of money. We're talking millions of dollars here. Why is it so expensive? Because you're using different types of materials, and you are really introducing a different modality, a different way of viewing something. So no longer do you have to literally be in a project, right? Now you can actually you can have an actual model. And in fact, from that same show, lots of real estate brokers actually sell projects based on those models. That's how useful they are. That's why people spend that money. You have engineer, biomedical. Jonathan actually mentioned that. This is one of my areas of interest. It's something that I would have studied after I finished my first 2 qualifications. Why? Because I think it's super cool where you blend biology, engineering, and medicine. For example, in prosthetics. Yeah. In fact, your 3D printing, one of the first set of serious 3D prints I saw people doing, like I shared with Jonathan, were veterinary prosthetics, as in using for animals, animal prosthetics. I found that to be really cool. And then it morphed from there and so on. I found that really, really cool. CAD technician designs components, drafts them, okay? 3D printing technician. Now, let me backtrack a bit. That CAD technician doesn't focus on the 3D printing. Their sole job is computer-aided design. That's it. That's their bread and butter. That's it. And then you have that 3D printing technician. Now, their focus is on, okay, how do we print this component? Because is it that it needs to be thicker? Is that what we need to tell the CAD technician? Do we need to tell them, okay, well, make it thicker here, give it more structure here, give it more infill here? So now you see why those 2 persons would have to work together, but still not doing the exact same job. Entrepreneurship, we actually have a guest for that. So I'm not going to go too deep in that. But 3D design and printing, I mean, each one of these persons can have their own business, from architect, engineer, to CAD specialist, to 3D printing technician and specialist. And you have prototyping. Very important. Prototyping allows you to rapidly develop something and test it. So you don't need to, tell somebody and try to make 100 of them before you can actually test them. You don't have to try to whittle away at a piece of wood or a piece of rock or some other type of material yourself, or call someone and say, hey, can you make this for me at an extremely ridiculous price because I'm only doing one of them? Nope. In fact, you don't even need to buy a 3D printer. It's that bad. You don't even need to buy it. Create your model, send it to a company that will take your print that one off or how many ever you need, and they just send it to you. Got it. Love it. Great entrepreneurship, by the way. Love that. All right, Jonathan, I think you're up.
Yeah. Yeah, so we want to talk about some of the roadblocks that persons may face when wanting to endeavor or venture out on a 3D printing project. And the first one that's most common throughout all, and we've mentioned this through all of our episode, is fear. And fear of what? Fear of change. Many persons are afraid of change, changing what actually works already, and taking on something new they don't like new. I've witnessed this in many departments where persons have resisted change for years because of that fear. And why? Because it would require them to learn. And when you learn, you gain knowledge. Knowledge is power, yes, but with knowledge comes also great responsibility. And many persons don't like the added responsibility that comes with knowledge. So that is a part of the fear as well. And then there's the general fear for technology. And yes, some of it is tied up with not knowing how to use it. But persons are afraid of technology because they think they are going to fail. So failure is a part of that, and it really, keeps back people from going forward. And we have created a professional learning network called the Google Educators Group, and this is not only in Barbados, or even this is not only in Barbados. This is throughout the entire world. You can join the Google Educators Group. This is a professional learning network where professionals and non-tech savvy persons can join together and form that and build that support group. So there is a GEG Caribbean and a GEG Barbados. There are GEG, as I said, all over the world, in America, in South America, in Europe. If you just Google GEG, you will see them there. And they're very active groups, persons helping out each other, teachers, parents, students, professionals. We want all of you who are viewing to join one of these GEG groups and participate in this change, this movement of advancing technology in education. Yes. So, and if you want to start your own GEG group, feel free to do that. If you want to start a GEG Trinidad or Jamaica, do that. And we can always link up with GEG Caribbean. So we'll be all a part of that one network. Another roadblock here is cost and funding. And persons may not be aware of it, but there is access to funding somewhere. Right, there is access to funding, whether it's grant funding, whether it's peer-to-peer funding, whether it's through different types of bond funding, or counterpart funding with different agencies. You can even ask for funds from other companies or community members within the school district. And these persons most likely will be willing to help because many of them have students, children in schools, or they may have started a project of that sort that is aligned with the school's project. Sure, as we always say, that your objectives are aligned with what you want to achieve. And then there's the fear of support and maintenance. You may have technology, but the question is, how are you going to support and maintain this 2, 3 years down the line? Well, one of the biggest concerns that comes out of this is, do I have access to the parts and the materials, and is the technical assistance available to me to use? Well, we know in these times, logistically, parts and things coming into the island is a bit difficult because of COVID, but there is means of accessing these parts and materials. And think about it. You purchase a 3D printer, which can manufacture and make almost anything. I would dare to say anything that you want to, right? So you can therefore manufacture your own parts. So switch from the consumer to the manufacturer. Yes, and then there is other technical assistant resources. You can speak or reach out to professionals like myself or Jelani, or even our guest from RedLab, who is going to demonstrate what he does in his company. Professionals I know out there that you can also reach out to. So if you want to join the GEG groups, as I said, feel free to reach out to us via GEG Caribbean or GEG Barbados, and we'll be happy to get you on board our support group. Now, if you've watched the show long enough, you know that we are men with plans. And we always want to bring something that you can use within your class or environment right away. And I will also say that the sample projects that we will demonstrate here are linked with the MOE curriculum for Barbados, and I'm quite sure they are linked with curriculums, in other parts of the world, wherever you are viewing from. So let's begin. So our first project will be at the primary level, and the subjects that or the topics we are covering here are mathematics, science, art, and history. And what we really want to do is to create props, maybe paperweights, door wedges, and other containers using the 3D printer. And you can discuss these critical points within your class when preparing to engage them in this project. And that is, you must determine the area are of regular and irregular shapes, measuring and calculating that area, and identifying and describing, what is the different angles, right angle and acute angle, and understanding density. You know, I have a demonstration here of the first one, which is the doorstop example. If we can bring that up. Yes. So this is the doorstop example. And imagine you are engaging in a project, a STEM project with your students that involves mathematics and art. You're touching two subjects at the same time. And you're also solving real world problems within your class. You have a door that keeps swinging back and forth and you want to keep it, open, then, or halfway shut. Then you could use a door stop. And instead of, purchasing something like this, you can actually manufacture it yourself within the class and have your students be a part of this process. So you can see here, I think we have a demonstration, if we can put it up, a video, do we? Of this process itself. Are we ready? Great. Great. So I'm using the actual 3D objects that exist on the Tinkercad tool, and I'm going to just manipulate it to get what I want. So if you don't have all of these skills in design, in CAD design, there are ways you can get around it. You can use existing objects or other graphics that would have already been pre-designed. So I am trying to set my measurements for my doorstop. I did mention before that we are dealing with angles, triangles, and I'm setting my measurements for my doorstop. And I had my student calculate the area of it, and they know the height, the width, the length. They know exactly what we are supposed to design here. All right, so after you're finished with this, all you would need to do is to plug this into the printer and print it. Once you have your PLA filament, the spool of your PLA filament, it will begin printing this layer by layer. All right. Let's go to our next example here, and this is understanding density. Now, I have three different cubes here. If we can get the picture up here to show you. Three different cubes that look the same, but they look identical, but due to infilling settings, I can print them to either float, sink, or to stay mid water. And this is the fill density, the infillment that I was talking about. Depending on how you print them, it would determine whether it would float, sink, or stay mid-water. If we can get about the other example there up, so you can keep your eyes on that. Right, so this example does come from the MOE curriculum, as for Barbados, as I said, and I know this is used in physics. So imagine a physics teacher having this printer and being able to print these cubes to conduct his or her lesson. And we can even go further. We can use this within art. In creating different manipulatives. We can use this within biology when we're printing like bone structures, bones are the cells are different parts of the body or different organs. When we want to demonstrate these types of manipulatives. And as I said before, you don't have to have all of the knowledge. You can use existing resources before, and these resources can be found on things like Thingiverse. I think people call it Thingiverse or Thingiverse. And then there is My STEM Kit. Using that as well, you can also find different lesson plans that you can just use right away within your classroom. And that is more for those ambitious persons who are willing to pay for the subscription for that. But there are really good resources on that website. And then there's Tinkercad for those who are adventurous and want to design things on their own. They can use Tinkercad to begin developing their own 3D models.
All right, Jonathan. So we're moving on to the secondary and tertiary levels set of lessons here that we want to share. Google Slides. This is the first time it gave me any trouble. Jonathan, what's going on? You got to give somebody some lashes, Jonathan. First time that ever happened. Gotta love it. Okay, so what I'm going to focus on here, the secondary and tertiary levels, are professional and educational manipulatives. Okay, what do I mean by that? I'm going to focus on things that really change the different modalities, or rather the different ways that we can access learning, and even as it relates to professions. So we're going to look at agricultural science and geography, just to name two of them, or two areas. And our aim here is going to be agricultural tools, focusing on those tools, and topographical maps. Okay. Um, our objectives here will be to use 3D design and 3D printing to create solutions for different learning and professional modalities. Now, pay attention to this point here, because what Jonathan showed you at the primary level can also be used at the secondary, tertiary, and professional level. In fact, at the tertiary level, you're really preparing students, you're preparing young people or whomever for that world of work, that professional level of work. Okay? And then we're going to discuss what additional information do you observe using these new modalities, this new way of seeing things, this 3D way of thinking, so to speak, using 3D design and 3D printing. All right, so we spoke about agriculture. Now, here you have a farmer, right? And look at how they're watering the plants, right? Just something simple, something that they came up with. I want to walk down a row and be able to water the plant beds on either side of me at the same time. Okay, so that way I don't have to go up and down twice, all right, or rather up and down. Now, in that same vein, here, when we think about creating, for example, agricultural tools. Now, no longer do you have to, let's say, buy a tool. So you don't have to wait till your friendly neighborhood retailer comes into, your neighborhood or your country. Nope, 3D print. Now you might be saying, well, Jelani, suppose I'm in a country where I don't have access to any of that. But here's the thing: you have people in Africa and people in other countries who are actually making 3D printers. Yes, I said it. How are they making 3D printers? Remember, a 3D printer is just simply the only difference between that and a normal printer is you're printing depth. That's it. Nothing different. That's it. And when I say depth, you could call it height too, but all you're doing is adding another dimension. So what's sweet about that is once you get those first two dimensions right, all right, you're good to go. And really and truly, you just need a couple of stepper motors, and you don't even need an enclosure. In fact, someone was saying you don't need to buy a printer that has an enclosure. All you need to do is simply throw a box over it. Do you get that? That's how people are thinking. That's how people are really solving problems here. That's 3D thinking. That's what we're really talking about. All right. So you don't need to go and get a metal tool. You can just print a very strong nylon tool, a carbon fiber tool. And by the way, it's lighter. Get it? Interesting, right? All right. Then let's look at topographical maps. Now, I want you to think here with me. You're in geography, and you're seeing on your book, in your textbook, a flat topographical map, right, of Barbados. Now, Jonathan actually showed a little bit of this in our AR VR segment in episode 2. But suppose we could actually add some more feeling to that. So here's what we do. Let's get some data points, and we already have that information. We can capture it from Google Earth, from our own Met Office, and our own government resources here. And we can actually create a 3D printed topographical map of the country. It doesn't have to be huge. It can be, but it doesn't have to be, or it could even be in parts. Why is this useful? Well, what's nice is now I can easily come and slide my hand over that map, okay? And I can, let's say, compare Mount Hillaby, which is our highest point, to our highest building. How tall is our tallest building in comparison to Mount Hillaby? That's interesting to me. I would want to know that. For example, when we look at Dubai and all these other places, they're always talking about we have the tallest building. Now, Barbados doesn't have the tallest building, but how tall are our buildings in relation to everything else, right? Really interesting. Okay, and again, 3D printed, yeah? All right, but let me blow your mind a little bit, and let me show you something here, something that I find pretty cool, where what you do is you actually have access to, what would I call that? Access to something that isn't 3D printed. It's just a 3D design. But you know what? It actually uses technology that we have mentioned before in a previous episode. It brings 3D design and it brings augmented reality together. I think you are going to like this. So here's what we're going to do. I'm going to show you a video that allows a person, okay, a video that allows a person to actually view their 3D design in augmented reality. All right. Now remember, I would have showed you, for example, mobile AR and VR. Well, we're going to do a bit of that, not too much, just a little bit. So here we go. I'm just trying to bring it up a second. It has decided it wants to run away from me. So let's just give it a second to load. When it comes up, what you're actually going to be able to do is use your own mobile phone and an augmented reality trigger to be able to look all around your 3D object. Now imagine how useful that is to someone who, let's say, maybe doesn't have a 3D printer. Think about that for a second. What we've just done is we have removed the need for you to even have a 3D printer if it's something that is difficult to afford. And in the next case, what you'll actually be able to do is you'll be able to, here it is, you'll actually be able to see it on your phone and look at that object. You can begin to observe that object. So remember that oven knob, right? Okay. So this is an oven knob that was damaged, and I recreated it using Tinkercad. And here you can literally pick it up using an augmented reality trigger. This is it here, this cube, an augmented reality trigger. And I can hold that in my hand and look all around it. Okay, I can examine it. Imagine a primary level student, a tertiary level student, a secondary level student, or even a professional using something like this. Very useful, don't you think? Something that allows all of these different persons at these various levels to now be able to engage 3D design and 3D, and without even needing 3D printing. Now, I think that that's something that is extremely useful. And now, we promised you, we said that we would bring a guest, and we have brought Mr. Delano Blackman. Jonathan, I keep forgetting. Is it myself or yourself that's doing the introduction? I came prepared, but I can't remember if you also did.
That's okay. That's okay. You can continue. You can continue.
You sure? You sure you don't have anything prepared behind the scenes? All right.
No, very good. Very good.
Okay. So in all seriousness, Mr. Delano Blackman is someone that I would have met and I would have connected to through another acquaintance, another mutual acquaintance. And Mr. Blackman actually owns his own 3D design and printing company. Now, I'm going to actually leave it to him to explain what he does, because it's something he's very passionate about. He got very deep into, and then he invested in it. I love it. I love the fact that he took that initiative. And that's what we're bringing here to you today, Mr. Delano Blackman. You're up.
Hey, good afternoon, everyone. Thanks for having me.
Hi, good afternoon, Delano. How are you?
I am.
Hey, good afternoon, sir. Good afternoon
Hi. All right.
as well. Hey, Delano, we are happy to have you here, and I'm very curious about your role at RedLab and why you decided to start this company. So if you could tell us and our viewers why, then I'll be happy to hear that.
All right. So right now, my role at RedLab is doing everything from 3D design to printing to post processing and all the admin processes in the background. Now, RedLab started as a bit of a hobby between me and one of my closest friends. Now, for a year or two, we've been hearing lots about 3D printing all over social media, YouTube, just seeing 3D printing over and over. So we got kind of interested and we got a 3D printer and everything just went off from there. It was watching prints go ahead. The first print we ever did, we sat and watched it. It took about an hour. I sat next to the printer the whole time. It was just pure bliss, right? Now, I think the reason that I really went ahead with it is because it's a new technology. It's advancing, it's growing every year, it's becoming more and more popular with persons, companies, schools, just about everywhere. I noticed a large percentage of engineers in Barbados were, for lack of a better word, fix it engineers, right? And I used to do that in my previous jobs, but I found that I prefer to be a creative engineer. So I like to produce stuff more than I like to fix stuff. Now, I think the final reason I would say Red Lab came about is because 3D printing allows us to bring manufacturing closer to home. So instead of having to buy and order parts all the way from China, the US, Europe, you could just have stuff made right here in Barbados.
That is great, Delano. That is great. And you said something that is important, something that we are trying to push even on this show, and that is using STEM as a method of thinking, of solving problems within our class that would boost inquiry and give students exposure to tools that they would, need in their future careers that could develop into careers. And you are an example of that. When you said that your friend and you decided to just buy a printer and watch it, not knowing that this was going to be what you'll do right now and for the foreseeable future. So that is great, Lama. But tell me, how, in your opinion, has 3D printing and design improved the quality of learning for you? How has it?
Now, first of all, I'm sure the viewers are wondering how a 3D printer works, so I think we should give them a slight demonstration while we talk about this. When I was going to school, well, here you can see one of the printers that I use. This is called a Creality CR10. This is my biggest printer. Oh, this one prints almost a foot by a foot cube. Remember, Jelani mentioned the height, width, and depth, almost a foot by a foot cube. So you can print some pretty big objects on this. The
I love
extruder,
it.
yeah, the
You want
extruder
to
head.
trade?
I think we may have to wait for that trade. Now, as it relates to school, while I was at school, I mean, it's a bit of a joke sometimes. I went to many different schools, but while I was there, you stay here and read about many different things. I never got the chance to see them, at least until I got into work. Now, 3D printing gives educators the opportunity to bridge the gap between hearing about things and actually having a reference in hand in the classroom. For example, look at this slide. This is a basic ball and stick kit that you will see very prevalent in chemistry classes. Now, locally, I've not encountered many of these in my chemistry classes when I was younger. And these are surprisingly cheap. But the problem arises where you get parts that are broken or lost. And if you had a 3D printer, you could print a kit like this in a couple hours, a full kit in a couple hours. Now,
A
another
full
reference,
kit. Wow, that's
yeah,
impressive.
Another example was like when I was at school doing engineering classes, I used to hear a lot about things like impellers and for pumps, that kind of stuff. And seeing it on paper didn't know justice to seeing it in real life. You can have an impeller like this in easily less than 2 hours. And you don't even have to design it yourself. I found this design online and just printed it just to see how well it would be done. And that's something that comes up quite often in engineering classes. Now, another way I think 3D printing and design helps with education is that the design aspect inspires innovation and creativity from students. Because we now have the technology that Jelani previously mentioned to create and dissect different real world objects and why they work or don't work. So now during a class, we can now iterate on different designs, just repetitively go over designs to find flaws, why things work, know how we can improve them in the future. And it's a lot cheaper to actually have a prototype made from plastic than doing it in class, trying to make it on a lathe, a milling machine, that kind of stuff. And it's much easier now.
Yes, great talking points there. So, where do you see yourself within the next 3 to 5 years, Delano? Where do you see yourself and Red Lab?
3 to 5 years, come to think of it, I think this is a pretty quick expansion because my first experience with 3D design was using things like AutoCAD, drawing objects in school for technical drawing, that kind of stuff. And before having a 3D printer, I never even had 3D printing experience. But during school, I found lots of different principles applied and stuff like using CNC machine coding. 3D printers also use that same code so you can edit your codes without or after the use of the slicer that Jelani mentioned. But in the coming years, I think the first goal for RedLab would be to become a household name in the manufacturing industry, especially locally. And then the second goal was to become a regional player, producing parts and stuff like that for different companies and individuals all over the Caribbean. And then the final goal, in my mind, for the 3D printing aspect of RedLab would be to have metal printing done locally. And I think that would be a pretty big deal because people have been asking about it already.
Great.
Yes, I will call you. I will call you. I will call you. I have
Funny
some
thing
ideas for
is,
that already.
I can already get you metal parts, but it's just not something I did yet already.
That's good to know, though. That's useful to know. I already have some plans for that. Thank you so much.
No problem at all.
Yes, and you feel free to keep us updated on what's happening with you. We're always interested in anything that involves STEM learning, 3D printing, anything that involves that. We'll be happy to keep in contact with you and probably have you on to show us your progress. Be a
Definitely.
career showcase for our viewers and our young viewers especially. So I think we are coming to the end of the show, and this is the part where we take some questions here. So if you have any questions, feel free to let us know within the comment section. We'll be happy to take those questions and answer them. You can direct them at myself, Jelani, or Delano, and we'll be happy to answer them. Now, if you want to contact us, Jelani have some contact information he wants to share with you. Let's go back. Right. You can contact Jelani at Jelani Payne, and that is for everything. Um, Instagram, Facebook, LinkedIn. I'm not even sure if you have Twitter, Jelani. You have that yet?
No, no,
You
no.
don't?
It's difficult for me to deal with Twitter. It's
Okay.
a bit difficult
Yeah.
mentally.
And then you can also contact Delano at RedLab246. I believe I have that correct. Yes. RedLab246. You can reach out to him. Also, I believe on his website as well. I think it's redlab246.com.
Yeah,
Yes.
definitely.
Yeah, so you can reach out to Mr. Delano as well. And if you want to reach us, it is at the EdTech spot for everything. That is everything. So feel free to reach out to us. If you don't have any questions, as we usually say, we're interpreting that as we did a good job in explaining the concepts here and you understand it well and you don't need to answer any questions and you're ready to go implementing these, it's really designed project within your school or environment. Yes. And by the way, if you want to provide feedback on this show or previous shows, you can do that using the feedback link that was posted. I believe it will be posted again within the chat area. You can provide feedback on the show. Feel free to reach out to us, as I say, if you want to join the show and may probably share some experience or something that you've done amazing within STEM in education. We'll be happy to discuss this further with you. And as usual, you know, we would promote the next episode at the ending right here. I don't think we have any questions. So, Mr. Payne, if you wouldn't mind giving them a preview of the next episode.
Absolutely. So, as Jonathan said, as is customary here in the STEM in Education series at the EdTech spot, we're going to tell you a bit about what's coming next. Episode 4, Managing Changes in the New Learning Environment. And guess what? There is a seriously new learning environment for educators and students and parents. Many educational institutions have decided to move forward with the method of blended learning, for example, during the COVID-19 pandemic environment. So episode 4 is going to be thought-provoking because we're actually going to have 2 guests. One, Mr. Chad Monaville, the CARICOM Youth Ambassador for Barbados, and Mr. Dwayne Matthews, a registered educator with the Ontario College of Teachers. He's also a Chief Innovation Evangelist and Future of Education Strategist. Sounds like a mouthful, but you know what? I've seen all of his social media. Trust me, this is the real deal. And these 2 persons are going to bring that fire when it comes to talking about that topic of managing changes in this new learning environment.
So the next show definitely sounds like one to look out for. Uh, Thank you all for having me. I hope the guests enjoyed the show. I learned something today. But for now, stay safe.
Thanks. It was great having you. Great having you as well.